Okay, here's another question, and it does involve a formula for h, the height of this arrow, with v squared on the top and 2g on the bottom. So we're going to be searching for different bounds if we're to calculate h. But let's have a look at this. Write down the upper bound of g. Again, how I do this is I write 9.8, leaving enough space on the left. What's the next number down from 9.8 in two significant figures? It will be 9.7. And the next one up would be 9.9. And if we draw in the goalposts halfway in between, we can then say that the goalpost lies at 9.75 and 9.85. And this will be the lower bound, and this will be the upper bound of our value of 9.8. So we've answered the first question. Now let's have a look at part 2. So they want the lower bound of h. Now, because the equation for h has got a numerator and a denominator, to get the lowest value on this side, we need the lower bound of v to get v squared, and we need the upper bound of g that's then multiplied by 2 to get the denominator. So let's work out the lower bound of v. Again, put v in the middle of the page, 24.4, and that's correct to three significant figures. The next one up will be 24.5, and the next one down will be 24.3. Here are your goalposts, and they're at 24.35 and 24.45. So putting numbers on our equation here, the lower bound of v, which is 24.35, so we need 24 squared divided by 2 multiplied by our answer from part 1. So I can get rid of that bottom bit now and just put that into a calculator, and we get 30.0975 ... Now they need our answer to three significant figures. So the cutoff point for three significant figures will be here. So our answer to three significant figures is 30.1, because we've got to raise the 0 up to 1 because we're cutting off 935, which is well above the borderline of 500. And we must write down that we've truncated this to 3SF. And that's your answer.